Hi everyone, so welcome back. So we just finished up our Unit 1B, so on center and spread, and now we're going to begin our next chunk of Unit 1, 1C, called Outliers and Skew. Okay, so we've talked about the word outlier before, we've seen them on displays, but in this unit we're going to actually figure out mathematically how we can determine if something is actually an outlier. And then we're also going to talk about how that outlier affects the rest of the data. Okay, so get your notebook out, get a pen out, here we go. So what are outliers? Here's your first definition of just what an outlier is. It's a data value that lies an abnormal distance from the other data values. Okay, it's separated from the rest. So whether it's floating out there way on the right as an upper outlier, or whether it's lower as a lower outlier, it's separate. It lies an abnormal distance from the other values. Okay, so what that looks like on a data display is this is a weird looking dot plot. The dots are on the number line, which is not right, but there's the outlier over there at 9.5. Here are two box plots, box plot A in blue and box plot B in red. And you can see the blue one has an outlier kind of floating out here at 60. So there's the outlier for box plot A. Okay, so the whisker ends here, right? And then the outlier is over here. Okay, and then here's a histogram. We have a bell-shaped curve over here where all the data is clustered, and then boom, here's our lower outlier, okay? All by itself, an abnormal distance, normal distance away. All right, you get the gist. Okay, so now we're gonna figure out how to actually mathematically figure out if this thing is an outlier, okay? I mean, it looks like one, but there's a formula to decide officially. So mathematically, how to find them, there's two ways. So if you still don't have your notebook out, get it out right now. We need to put these rules into our notes. Okay, the first one is called the IQR rule. What it says, so we have to do some calculations. We're gonna get a number. If your number is less than this number here, if any data point is less than this number, then that's an outlier. If any number is greater than this number, well then that's an outlier. So what these are called are the fences. So you're finding the fences. So you have an upper fence and a lower fence, right? And so what that means is like this is the lower fence. If any, you're gonna get a number here. In any outlier that's less than that, okay, that's definitely an outlier. Any data point that's greater than this number, that's the upper fence, that's an outlier. Okay, so you're essentially like fences or like brackets or boundaries, whatever you want to call them. But the IQR rule tells you how to calculate these fences, okay? You take whatever your quartile 1 is, you need to find your IQR. First, you multiply your IQR by 1.5 because order of operations, and then you subtract it from Q1. And then you take this number that you just calculated again and you add it to Q3 to get your upper fence. And any data points that lie outside these fences are outliers, okay? We're going to see an example that will make more sense, but at least you have the formulas down for now. The second rule is called the standard deviation rule. Okay? It's just a different calculation to find the fences. Instead of doing this Q1 minus 1.5 times the IQR, what you're going to do is you're going to take the mean. Remember, this symbol is for the mean. Here and here. You're going to take the average or the mean. And you're going to subtract from that 2 times the standard deviation. So you're going to take whatever the standard deviation is, multiply it by 2, subtract it from the mean. That's your lower fence. Then you're going to take 2 times the standard deviation and add it to the mean. That's your upper fence. Any number lower than your lower fence is an outlier. Any number greater than your upper fence is an outlier. Okay, so here it's important to note, actually essential to note, that this symbol right here, X bar, is called the mean. We know our standard deviation is SD. Okay, just a reminder that X bar is the mean. I think I did mention this before too. All right, so 2 rules to figure out how to find an outlier. We can use the IQR rule. We can also use the standard deviation rule. All right, let's see them both in action. Example 1. Here's a dot plot. It's talking about the number of home runs hit by Giants players in 2014. Sure. We got some cluster going on here. I'm just looking at the shape. We can clearly see it's being pulled down to the right, so it's skewed right. We got some numbers over here that look an abnormal distance from the rest of them, but like, how do I know? You know, maybe I need to do some calculations to see actually, you know, which ones are the outliers. So the directions say use the 1.5 IQR rule. Now I know which rule I'm using, and then I can circle the ones that are actually outliers. So we need to figure out some outliers here. It's also important that they give you some stats. So they give us this nice summary here. N means that there's 20 dots. We have the mean, we have the standard deviation, we have the minimum, Q1, median, Q3, and maximum. A lot of good information here, just given to us right in the directions. And so all we need is the IQR. Okay, well we know that the IQR is Q3 minus Q1. So all you're going to do is you're going to take 6.5 minus 0.5, and you're going to get the IQR of 6. Okay, that's going to help us run these calculations to figure out our fences, right? We need the IQR to start. So our IQR is 6, so we can write that down, note that for later. Okay, number of home runs by Giants players in 2014, we have an IQR of 6. So now we need to figure out these fences. Let's do the lower one first. Formula says, take 1.5, multiply it by the IQR, and then subtract it from Q1. Let's just plug in what we know. I know Q1 is 0.5. I know my IQR is 6. We have to remember order of operations. I don't know why these parentheses aren't in here yet, but we're going to do this multiplication first. We're going to take 1.5, multiply it by 6, and get 9. That means your lower fence is going to be 0.5 minus 9, and it's totally okay if it's a negative number. Most likely it will be a negative number. That means our lower fence is negative 8.5. That means any number less than negative 8.5 is an outlier. Okay, we'd have to go look back at the dot plot just to make sure. Let's see the upper one, because that's the one we actually care about here. Q3 plus 1.5 times the IQR again. Let's do the multiplication first. 1.5 times 6, I just did it. I told you that's 9. So you take Q3 now. Notice how it's not Q1, it's Q3 now. And we're adding these to get our upper fence. So 6.5 plus 9 gets me an upper fence of 15.5. So any number bigger than 15.5 is an outlier. So let's go back to our data and see. Here's my dot plot. No numbers are in the negatives, so I don't have any lower outliers. But I do have some numbers that are bigger than 15.5. Pause here and see if you can figure out how many outliers are there, right? Which numbers are less than negative 8.5 and bigger than 15.5? We came up with that there are no lower outliers, but we have some upper ones. 16 right here, 20, and 22 are all outliers, right? They're all bigger than this upper fence of 15.5. And I'm glad I did this calculation out, right? Because I think this is an abnormal distance just by looking at it, but to make sure mathematically we need this formula. Okay, so you would conclude, okay, based on the fences, there are 3 outliers, 16, 20, and 22, and you get 100 on this problem. Okay. Example 2, we're going to run through the standard deviation rule, and then we're going to call it a day. Here's another dot plot. We're talking about life expectancy by country. Interesting. There's another summary table. Now we're going to use the standard deviation rule. Let's see what it looks like in action. Well, the standard deviation is given to you literally right in the table, so there's no calculation needed. You just have to make sure you copy it over right. 9.452. Let's find our lower fence. The formula is, remember this means mean. Mean plus 2 times the standard deviation. Remember, we're going to do the multiplication first. The mean was also in the table if you look back. I'll show you. The mean is also right here, so I guess we needed that. Mean is right next to it, 72.174. Okay? We need the mean, we need the standard deviation. I'll always give you those. You just have to make sure you plug it into the formula correctly. 2 times 9.452. Take that number away from 72.174. You're getting this lower fence of 53.27. So anything lower, right, this is lower. Anything lower will be an outlier. As far as the upper fence goes, all that changes is instead of subtracting the numbers, you are going to add them. Okay? When you add 72.174 and this 18.904 number, we're getting an upper fence of 91.078. Remember, this is upper fence, so anything higher than that is going to be an outlier. So let's just go back and look at our dot plot. We're remembering our fences. Anything lower than 53.27 is an outlier, and anything above 91.078. We know there's nothing beyond 83, so we don't need to quite worry about this upper fence, but we do need to worry about this lower fence. Pause here and see if you can figure out which dots on this dot plot are the outliers based on this lower fence. Okay, are there any dots lower than 53.27? I found one, hopefully you just found one. This right here is an outlier. 50 is the only outlier based on our calculations. Okay? Those are the formulas. Okay? That's the only really concrete math we're going to see in this unit. The rest of the unit is more conceptual. So it's talking about like, how do outliers affect the rest of the data? So once we know that this 50 is an outlier, what does it do to the rest of the data? What does it do to the mean? What does it do to the median? Okay, so let's talk about that idea in a sec. So here's another good definition for your notes. It says a statistic that is resistant to, being resistant to something. It doesn't change, or it changes very little after an outlier is added. Okay, so a statistic such as like the mean, the median, or the mode, those are all statistics. Something that's resistant to outliers, it doesn't change, right? If you're resistant to something, you're holding your ground, you're not changing, okay? But something that's influenced by does change. And we're going to talk about, you know, which stats are resistant to outliers and which stats are influenced by outliers. Okay, so once you have these in your notes, go to the next slide here. And we're going to talk about which stats are resistant and which stats are influenced. Just those 6 major stats, the 3 measures of center and the 3 measures of spread. So I want you to pause on this slide. Here's the 3 measures of center. You have all the centers right here. And here are the measures of spread. And what I want you to do is try to predict, you know, where they're going to fall on this chart. So there's 6 spaces, perfect, they'll all fit. But it just depends on like which side you're going to put them on. Do you think the mean is influenced by an outlier being added or resistant to an outlier being added? You know, if I give a test and someone doesn't come, so they get a 0, what's that going to do to our average? Is our average going to change? Well, if it's going to change, it's going on the influenced side. But if it's not going to change, it's going to go on the resistant side. So pause and predict and see where you think these stats will fall on this chart. And I'm going to give you the answers right now. So I just talked about the mean, right? This person getting a 0. Well, they're definitely going to influence our average. Okay, they're going to pull our average very far down. The average or the mean is influenced by outliers heavily. Okay, the median, well, the middle number, if I add a 0 to the list, the middle number is not going to change, or it's going to change very little. Okay, the average will be more affected than the median. So we're going to say the median is resistant to outliers. If we take a test and someone gets a 0, is that doing anything to the mode? Well, the mode is just the most common. If the most common gets an 88, I mean the mode stays the same, or it changes very little. So the mode isn't really affected by this outlier of 0 being added in. Now I need to go through the measures of spread. Well, the first one is the range. If we range from 80 to 95, that's a good range. But now if a person gets a 0, we range from 0 to 95. And that's a huge range. That means the range is super influenced by outliers, as well as the standard deviation, right? Instead of ranging from 80 to 95, now we're ranging from 0 to 95. We're spreading our data points out a lot. So the standard deviation is also influenced by outliers. And that leaves IQR to fall over here. It's resistant to outliers. I add in a 0, and my Q3 and my Q1 don't change a lot, which means my IQR doesn't change a lot, so it's resistant to. This is a super important chart. Please have it in your notes. We're going to talk about it and practice it a lot in class. All right, thanks for watching.